this is it. This is the end of chapter 5, the third and last part we're going to do for chapter 5, which is a really, really short chapter right now. So chapter 5, this last part has to do with function notation. Now remember, a function is a special kind of relation, right? Where every x value has only one y value. So can't have more than one y value. So in other words, if you can solve it as y equals, that means it's a function. And quite often we'll write it as f of x equals, right? Function of x is equal to whatever this is. Now this one's a straight line. Now the notation. So here we go. It says, so what is the y value if x is equal to 16? So if this is my equation, right? If this is my line, if I take the 16 and I plug it in for the x, all it really means is the y value is 3 times 16, which is 48, and then I'm going to go minus 4. So the y value is equal to 48 minus 4, which is 44. Okay? That's all that means. So what is the y value when x is equal to 16? So if I was actually graphing this as an x and y point, blah, 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 when the x value is 16, the y value would be like 44. So it'd be way up here or something. Yeah, but we know what this thing looks like. How about this one? What is the y value when the x value is negative 21? So way over here to the left. So if the x value is negative 21, so in other words, I'm taking negative 21 and I'm plugging it into the x right there. So the y value is equal to 3 times negative 21, 3 bracket, negative 21 bracket, minus 4. So negative 63 minus 4 is going to be negative 67. Yeah, because it's minus and even more minus. Minus 67. Great. What is the y value when x is 106.5? Same thing. All I'm doing is I'm just taking 106.5 and I'm plugging it straight into there. So the y value is, okay, this is getting tedious. This is taking way too long. 106.5, right? So I go 3 times that, then I'm going to go minus 4. So this is going to be 318, 319, 319.5, take away 4. It's going to be, the y value is 315.5. Okay, so yeah, I'm not graphing that thing by hand to figure that out. But that's all this really means. So here's what I'm doing. All I'm doing is I am plugging in an x value, because this is x is equal to this, into there. So see all this work, y is equal to y. I'm showing my work. There's a shorter way of doing this. Instead of writing it all out, here's what we can do. We can use function notation. What? In other words, it's a notation. It's been invented. It's kind of a shortcut for showing all this work. Okay? So here's really what this means. Let's go back to the exact same thing. So instead of y is equal to 3x minus 4, okay, now I'll call it f of x, function of x, but it's the same thing. It's going to be the same one, 3x minus 4. Okay, so f of 16 normally is f of x, right? So here's what they're doing. They just told you that the x value has been turned into 16, right? X is 16. So they're telling you x is 16. So in other words, that means I'm going 3 times 16 minus, hang on, we already did that, right? 3 times 16 minus 4. Yeah. So this is equal to, so in other words, it's equal to 44. What is that? Is that x equal to 4? No, no, no. Remember the x value is 16. This is not x. What is this? Oh yeah, the y value is 44. Oh yeah, so this means the y value. Now, remember, wherever you see f of x is the exact same as saying y. It means the same thing. So instead of saying f of 16, I could say y is equal to. I could say y is equal to 44. But you know what? We're going to leave it as this. It means f of 16 is equal to 44. So this is telling me when the x value is 16, the y value, that's really what this is, right? The y value is equal to 44. Okay, well, let's get rid of that y. Boop. So this is just a shorter way of writing it all out. So f of negative 21, right? When the x value is negative 21, remember we plugged this in, we got negative 67. So in other words, f of negative 21 is equal to negative 67. Done. This is telling you when the x value is this, the y value is equal to negative 67. Right? So the x value is always the inside part. It's not f times, it's a function of. So this is always the x. And we always do them as f of x. And that's what we're going to be doing in grade 10 and grade 11 and mostly grade 12. And a little bit in the calculus course, you start messing things around. You do different stuff like that. But yeah, it's going to be functions of x. Okay, so let's try it. Here's this function of x. It's x squared plus 3. So let's figure out what's f of 7. Well, f of 7 just means take 7 and plug it into there. So it's 7 squared plus 3. That's all it means, right? Instead of writing out what is the y value when the x value is equal to this and then showing the work, that's all this question means. This is just saying what's f of 7. So I know it's going to be 7 squared plus 3. 49 plus 3, that is equal to 52. Done. F of negative 22. So careful, it's negative 22. That's being squared, right? Because the x value is negative. Now when I square it, I know it's going to become positive. And then I'm going to go plus 3. So 22 times 22, well, it's 121 times 4. It's going to be 484 plus 3. It's 487. Done. That's it. There's no work to show, right? I'm just squaring that number and going there. So in other words, the y value is 487 when the x value is negative 22. So this is just saying plug in negative 22. What's f of m? What? In other words, take m, plug it into there. So it's m squared plus 3. It's not a number. It's some kind of function. It's some kind of equation. What's f of happy face? This just means plug in happy face. So it's going to be happy face squared. Happy face squared plus 3. That's all it is. F of dump truck would be dump truck squared plus 3. Okay, so that's all this means. It means the x value has been turned into a happy face. It's not a very happy face. It's kind of sad, but okay. So what about this? 5 times f of x. Now careful. It's not saying x is equal to 5. It means 5 times the entire function. Here's the entire function, right? F of x is equal to this thing. So that's the entire thing is going into there. So in other words, it means it's 5 times the function. And the function is x squared plus 3. X squared plus 3. Okay, so I can expand this all out. We know we're going to get 5x squared plus 15. Done. That's it. Now, it's a function of x. See that? It's a function of x. It's got x's in it. These were numbers, so the answers are going to be numbers. This is something to do with m, so this is something to do with m. This is something to do with x. This is something to do with x. Okay, what about this one? F of x plus 1. So in other words, x plus 1, right? I'm going to go back to here, and that's what I'm plugging in into here. So instead of plugging in m, or happy face, x plus 1 is going to get plugged into there. So here's what I get. It's x plus 1 squared, and then plus 3. Now, can I expand that all out? Sure can. Remember, this is x plus 1 times x plus 1. X plus 1 times x plus 1. I remember this. X times x squared plus x plus x plus 1 times 1 is 1. Careful, not 2. So here's my answer. I'm going to get x squared plus 2x plus 1 plus 3. So plus 4. Done. That's what it is. Now, so this thing is, it's got x's in it. Yeah, it's got x's in it. Whoa, what about this thing? 17 take away 2 bracket times f of 6. So kind of like doing bed math and stuff like that, we'll work from the inside out. Let's figure out what f of 6 is first. In other words, 6 is getting plugged into my function. So 6 squared, 36, plus 3. So this becomes 17 minus 2 times, what was 6 squared plus 3? 36 plus 3 is 39. So I'm going to go 17 minus, hang on, I do the multiplication before I do the subtraction, right? Oh, that's right. So it's really going to be 17 take away, well, 2 times 40 is 80, so this is going to be 2 less. 2 minus 78. Or sorry, 17 minus 78, which is going to give me like negative 61? Yeah, negative 61. Okay. This was a number, which means my answer is going to be a number. Okay, now let's change it up. Let's find the x value such that f of x is equal to 84. Careful. This is not saying x is equal to 84. That's not. That would be this. What's f of 84, right? That's what that means. That's not what we're doing here. No, I don't want to do that. So I'm not plugging in 84. It's a trick. Do not plug it in. It's a trap. This is saying the function is equal to 84. Well, what is the function? Let's go back up to the original here. F of x, this was, here's the function, here it is. It's x squared plus 3. So that's what I'm going to be plugging in. I'm plugging in x squared plus 3. That's what the function, see, it even says f of x equal to x squared plus 3. So that, I can take it down here. Come on. And plug it into there. Okay, let's get rid of this. So in other words, here it is. It's going to be x squared plus 3, right, equal to 84. Okay, that's an equation. Oh, that's right. So look, I'm solving for the x value. In other words, they want you to solve for x. Okay, minus 3, minus 3. X squared is equal to 81. Oh, so now what? I can do the square root, square root. So in other words, x is equal to 9? Hang on, could it be negative 9? Oh yeah, negative 9 squared would also give me, or there's actually two answers. If you ever have to do the square root, think about it. It could have been positive or negative, right? But typically this is going to be the most common one you get. There might be two. If you get x squared is equal to 81, the squared means you could get two answers. Okay, so in this case, they didn't want you to plug in 84, but they're saying the function is equal to 84. So I'm setting up an equation. Okay, so that's great if you actually have a function to deal with. Yay, there it is, right? What if you don't? What if it's expressed as a graph? Well, then I'm screwed because I don't have an equation. I don't know the equation of this beastie. This is just a diagonal line and then a flat line, and then it's like a half of an ellipse and then a flat line and another diagonal. Yikes. This thing is a mess. So, but that's my function. I don't know I don't know the equation. However, we can still do this. So if this is f of x, and they'll usually say y is equal to f of x, and they'll say it's this weird function here, f of 4. Well, normally that means plug in the x value of 4, right? That's really what it typically means. Okay, well, when the x value is 4, what's the y value? Boom. Right? When the x value is 4, the y value is 2. See? Yeah, the y value is 2. So how do I say the y value is 2? That's what this thing is. Go away. Right? This is like saying y is equal to, oh yeah, f is the same as y. So when the x value is 4, the y value is 2. Done. There's no work to show. All I'm doing is I'm reading it off the graph. If the x value is 4, what's the y value? The y value equals 2. I don't need to say y equals 2. I don't need to, because that's what this is saying right here. It's saying it for me. It's just a shortcut notation. Okay, so let's try this one. When the x value is 1. When the x value is 1, the y value is, look on the graph, there it is. Y value is 1. F of 0. Okay, let's go back to the graph. When the x value is 0, in other words, in center, the y value is, it's positive 2. What about f of negative 4? When the x value is negative 4. Negative 1, negative 2, negative 3, negative... Oh yeah, right there. So that point on the graph. Now, I'm not looking for other stuff here on the graph, but I'm looking for where is it on this weird shape graph. Well, okay, yeah, I completely missed there. So when the x value is negative 4, the y value up and down is 0. How about this one? It says, what is the x value if f of x is equal to 4? In other words, that's like saying y is equal to 4. So if the y value is 4, tell me what the x value is. Oh, that's what this means. Okay, let's get rid of all this junk. I've made a mess out of this graph. So if the y value is 4, that's not here, that's the x value. So if the height is 4, there we go. What's the x value? Boom, that point right there. The x value is positive 5. Right? So when the y value is 4, and there's only one spot for this one, the x value is going to be positive 5. So don't say that this is equal to 5, because that's not right. 4 is not equal to 5. Right? That's 4. That's 5. They're not the same thing. So don't say 4 is equal to 5, because they're not. But what's equal to 5? Oh, wrong one. What's equal to 5? Is it the y value? No, they're telling you the y value is equal to 4. It says find x. So in other words, x equals 5. That's my answer. Okay, so the assignment for this is it. We're done with all the functions. This is really just plugging in or reading it off a graph. Okay, so the function notation worksheet, this is an old worksheet that I had from before. Here you're just taking these numbers and plugging them in. Here's my equation, right? Plug in 2, plug in 3, plug in 0.5, so 1 minus 0.5 squared. These are going to be numbers. Same thing here. Now here, instead of calling it f, now they called it g. Big deal. It's the exact same thing. G is also a function. It's just usually the one right after it, right? It's just a different function. Okay, so g of x. So plug in 1, plug in 5, plug in a half, right? 3 times a half, 3 halves, minus 1. What about here? Here they don't give you an equation, but they give you a graph. Okay, so for A, they want you to find f of negative 2, f of 1, f of 3. So when the x value is negative 2, when the x value is negative 2, y value is 2. When the x value is positive 1, so go back to here, positive 1, the y value is 4. And when the x value is 3, 1, 2, 3, y value is, looks like it's 2. Ta-da, that's it. There's no work to show. So I'm just looking at when the x value is this, what's the y value? So it's really looking at this curve. And yeah, this is a weird curve. This one's got a curve, and then it's got another curve over here. What about this one? This is some kind of weird shape, comes down, it's a curve, but these are functions, right? I know because I can draw a vertical line anywhere, and it only hits it once, right? It's always hitting it exactly once. Yep, that means it's a function. So same thing here. Now I'm just plugging in not actual numbers, I'm plugging in m, or I'm plugging in x. So in other words, I'm just going to get something to do with x's, right? Same thing here. These are just going to get gradually a little bit bigger. So I find f of 2. Take 2, plug it in. Take negative 5, plug it in. Take 0.5, plug it in. And then this last one. So the answers are included on the back here. So I wish you good luck with it. And just like that, we're done functions. Okay, so look for the link for the quiz because I've made up a function quiz number 1. And good luck with this.